Hello and welcome. Today, we're diving into a really crucial piece of AI technology. It's called Retrieval-Augmented Generation, or you'll hear it called RAG. This is pretty much the secret sauce that's turning large language models from, creative but kind of unreliable storytellers into genuinely knowledgeable assistants you can trust. So let's get into it and see how it actually grounds AI in reality.
Okay, just take a look at this statement. This was generated by an AI, and it is completely factually wrong. It's a pretty startling example of what can happen when AI just goes off the rails, and it perfectly captures the exact problem that a technology like RAG was built to solve. So that really brings us to the big question here, right? Why do these incredibly powerful billion-parameter models sometimes just make things up? And with so much confidence, too. The answer? Well, it gets to the very heart of how these things actually work. Right, so this whole phenomenon of AI confidently stating things that aren't true, it actually has a name: hallucinations. And believe me, it is one of the biggest hurdles we have to overcome to make AI a truly reliable tool for all of us. Okay, so here's the root of the problem. Large language models, or LLMs, are trained on a fixed snapshot of the internet. They literally have a knowledge cutoff date. But what's even more important is that their job isn't really to know things. It's to predict the next word. So when you ask a question that they can't answer from their training data, they don't just say, "I don't know." Nope. Instead, they predict the most statistically likely response, which often sounds totally correct but is completely made up. And this is not just some quirky little bug. It has massive real-world consequences. This number right here, that's the hit Google's stock took after its Bard AI gave a wrong answer about the James Webb Space Telescope during a public demo. Ouch. When trust is everything, hallucinations are incredibly expensive. You know, this quote from Amazon Web Services is just the perfect analogy. The AI is like that new employee who is super enthusiastic, wants to help, and has a great vocabulary. But they're working from an old, out-of-date company manual and will never, ever admit that they don't know something. So how do we fix this? How do you give that super enthusiastic employee access to the company's live, up-to-the-minute information? Well, that's exactly where our solution comes in: Retrieval-Augmented Generation. To put it simply, RAG is basically a framework that gives the AI an open book test. So instead of just relying on its own memory, that static training data, it gets to look up the answer in a trusted external knowledge base before it even tries to speak. The key part is right in the name. It retrieves facts first, then it generates the answer. And the slide just breaks it down perfectly. On the left, you've got your standard LLM. It's kind of like a brain in a jar. Its knowledge is totally limited to its internal static training data. And its biggest weakness? It's prone to making stuff up, hallucinations. But then on the right, a RAG-enabled LLM has this lifeline to an external live database, and that is what grounds the AI in verifiable current facts. Okay, so that all sounds great in theory, but how does this thing actually work under the hood? Let's walk through the whole process, step by step. It's actually pretty cool. So the first step happens before you even ask a single question. You take all your external knowledge, think of all your company's PDFs, internal wikis, or product manuals, and you get it ready. This data is broken up into smaller chunks and then converted into these numerical representations called embeddings. You can think of this whole process as creating this hyper-organized, super searchable library where everything is stored not by alphabet, but by its actual meaning. Now, when you ask a question, your query also gets turned into one of these numerical embeddings. The system then uses that to do what's called a semantic search of that library we just built. It's looking for the pieces of text that are most conceptually similar to what you asked. It's a search for meaning, not just for keywords. And here it is, the magic A in RAG: augmentation. The system takes the most relevant info it just found and literally augments your original prompt. It's kind of like telling the AI, okay, the user wants to know about X. To help you out, here are 3 paragraphs straight from our official documents that contain the answer. Now go ahead and respond. And finally, the LLM gets this context-rich prompt. With all the necessary facts right there in front of it, it can generate an answer that isn't just plausible, but is actually grounded in the data you provided. The final answer is now based on truth, not just whatever it remembered from its original training. So that's the process. But why does all this matter so much?
Let's talk about the practical payoff and why this is truly a game changer, especially for businesses. The benefits here are huge, particularly for businesses. First off, your answers become way more accurate. Second, the information is always current because you can update that knowledge base whenever you want. Third, it's a lot more cost-effective than constantly retraining a massive LLM from scratch. Fourth, it builds trust with users because the AI can actually cite its sources. And finally, it gives developers way more control over the information the AI is using. Let's look at a really clear example. With RAG, a customer support chatbot can answer questions based on the absolute latest version of your company's return policy or product manuals. No more telling customers about a promotion that ended last week. Or, hey, imagine you're a financial analyst. You could use RAG to query a live feed of market data, news articles, and internal reports, getting an instant, synthesized answer to a super complex question, all of it grounded in up-to-the-second information.
And really, for any company, RAG can power an amazing internal knowledge engine. It unlocks all that valuable information that's just trapped in HR documents, technical guides, and company wikis, letting any employee get an instant, reliable answer instead of wasting hours searching for it.
Now, it's really important to be realistic here. While RAG is a massive leap forward, it is not a perfect, magical solution. It definitely comes with its own set of challenges. This slide points out the two biggest limitations. On the one hand, RAG reduces hallucinations, but it doesn't totally eliminate them. The AI can still misinterpret the factual data it's given. On the other hand, the quality of the output is completely dependent on the quality of your source data. You know the old saying, garbage in, garbage out. This actually leads to a really key challenge called RAG poisoning. This is what happens when the system retrieves a source that is technically correct, but is super misleading without the proper context. Remember that Obama quote from the beginning? The AI likely found the title of an academic book called Barack Hussein Obama, America's First Muslim President with a question mark. It grabbed the words, but it completely missed the rhetorical nature of the title, and that led it to state a falsehood as a fact. Okay, let's bring it all together. If you remember anything, remember these three things. 1. The problem. Standard LMMs hallucinate because their knowledge is frozen in time. 2. The solution. RAG connects them to live, factual data, giving them that open book test. And 3. The impact. RAG makes AI profoundly more reliable, more trustworthy, and way more useful for real-world business. RAG really is a foundational step in moving AI from a world of plausible fiction to one of verifiable fact. And that leaves us with a final, really powerful question. What becomes possible when our most powerful tools are finally truly grounded in truth? If you want more explainers on the technology that's shaping our world, make sure to subscribe to the channel. Thanks so much for watching.